Welcome to the lecture on the course Descriptive Statistics with R software. You may recall that in the earlier lecture we started our discussion on the association of variables, and we had considered how to construct the bivariate plots using the command plot, and we had used different types of option to create more interactive plots. Now, when we are trying to use the plot option to create the scatter plot, then we would like to have two types of information. One is the direction or the trend, and second is the magnitude. And the magnitude was decided on the basis whether the strength of the relationship is strong or say moderate or weak and so on. So now the question is this: by looking at the scatter diagram, how you would know that whether the strength is more or less. So in order to do so, we had created a line manually, but now that can be done on the basis of software also. So now we are going to consider the plots where we will create the scatter plot, and we will also add a smooth line, and that line will give us a sort of fit, and by comparing the observation with that fit, we can compare whether the strength is less or more, or this is weak or strong and so on. So in this lecture we are going to consider the scatter smooth plots. So now we assume that there are two variables and those variables are related, and we have obtained n paired observations, say x1 y1, x2 y2 up to here xn yn and so on. Now the objective is that we want to create a scatter plot, and inside the scatter plot we want to have a line which is called as fitted line. Why this is called as fitted line, that will be clear to you after some lectures. And when I try to do so, this type of graphics will provide us the information on the trend or relationship between them. And in order to construct such a graphic, in our software we have a command scatter.smooth, SCATTER.SMOOTH, and this command produces a scatter plot, and it also adds a smooth curve to the scatter plot. So now how to do it and what are the details? So this function, actually this command scatter.smooth, this is based on the concept of LOES, LOESS, actually is a locally weighted scatter plot smoothing method, and this is used for local polynomial regression fitting. And in this case it fits a polynomial surface which is determined by one or more numerical predictors using the local fitting. Definitely I am not going to discuss about the details about the LOES and so on, but we are simply going to use it, and I thought that because you will see that later on there are some options, the details are written in terms of LOESS, so I thought that I should tell you so that you do not get confused at a later stage. Well, if you want to have more details about this scatter.smooth function, please look into the help of this command and you will get more details. Right. So now the more detailed command of scatter.smooth, which will give you a scatter plot and a smooth curve, is the following. You can see here the command is the same, scatter.smooth. Now I am trying to give here the data here x and here y. Y is here actually null because we are trying to make it only with the one variable, but if you want to make it bivariate plot, you can use both x and y data. And then there are different options here as say span. Span controls the smoothness for this LOES, and this then there is a degree. So degree here is given as here 1. This degree is the degree of the local polynomial which is used for fitting, and then it is asking for family. This family can be symmetric or Gaussian, and well, there are different methods for fitting the data. So in case if we are using the Gaussian is indicating that the fitting has been done on the basis of least square method. He will consider the least square method at a later stage. And in case if the option of symmetric is used, then this is indicating that ascending M estimator is being used to get the polynomial. And similarly, if you want to give the labels on x axis or say y axis, then these are the command xlab and ylab here. And similarly, if you want to give the limits, for example, if you want to provide the limits on the y axis, then this is given by ylim, and then this is the range. If you remember, range gives you the two values, minimum and maximum, that we had discussed, and after that if you are handling with the missing data, then you have to use the command na.rm is equal to true or false. So there are some more options available, but I would request you that you please try to look into the help menu and try to understand how to use them. Now I will try to take an example and would show you that how to plot such graphics. So I am going to consider the same example which I discussed in the last lecture, where we have obtained the data on the marks obtained by the students out of 500 and the number of hours they studied in a week, and this data was obtained for 20 students, and this data here is given like this. The first row here in this case is the marks of the students out of 500, similarly here also. So these are the marks students have obtained, and the second row is giving the information on number of hours they have studied in a week, like it's here. Okay. And this data I already have stored in two variables. One I am calling it here marks and hours, exactly in the same way as I did in the last lecture. Now after this, I would like to create a scatter plot with a smooth curve using this data, and for that I use the command scatter.smooth, and inside the argument then I try to give the name of the variable, say hours, and here marks. And if you try to see here, this is the graphic that we are going to obtain. Right, you can see here now these points are the same point which were occurring only in the scatter plot that we had constructed in the last lecture, but now there is a line which is added to this thing, and this line is helping us in knowing that how much is the deviation of this individual observation from these points, and if these deviations are less or if these points are lying very close to the line, I can say that the strength is quite high. Suppose if you had got the same data with this line, and but the points are lying here and there and so on, right? Yeah, this may happen. Then in this case I would say that the strength is weak, or the degree of the linear relationship is weak in this case. So this is how we try to do it, and now I will try to show you on the R console also. That how to operate it. So I already have entered the data on say hours and here marks, you can see here, and I try to make it here a plot scatter smooth by this command, and you can see here we are getting the same curve what we have shown here, right. Okay, so now let us come back to our slide, and now if you try to see, I am taking a very small data set here, and I am just trying to consider 10 values, and these 10 values are indicating the weight of 10 bags of grains, and this data which is recorded here for 10 bags in say kilograms, this is stored here inside the variable weight, right. And I am trying to plot the scatter smooth graph for this data set, and this is plotted here, and the graph comes out to be like this. So you can see here these are the points, and this is indicating that possibly the relationship is not actually linear, but it is a sort of non-linear relationship. And please keep this figure in mind, because I will try to give you some more information later on using the same data set. Okay. And if you want to plot it here on the R console, I can copy this data here and right, this comes out to be like this. And if you try to see what I am trying to do here, I am simply trying to make a scatter smooth plot of this thing, and this comes out to be like this. One thing what you have to notice here, that in this example I have used only here one variable. So, you can see in this graphic that the value on the x axis, this is only an index. So, what we are trying to learn here, that is scatter smooth command can also be used for getting the curve only for univariate data when we have only one variable, right. And now I will take an example where there are some more number of data set, and I will try to show you how this curve look like in the univariate case, single variable. So, I have collected the heights of 50 persons like this. This is the same example that we have considered earlier, and this data has been stored inside a variable here height like this, and based on that I will try to create a scatter smooth plot of this data here in height. So, you will see here this looks like this, and it is indicating, well, this can approximately be a sort of linear relationship, but it is indicating that the relationship here is curvilinear. On the x axis, this is only the index of the observation, and on the y axis these are the values of heights. The reason why I am taking here this graphic is that later on I want to create another graphic on the same data set, and I would like to compare both of them together. But if you want to see the same graphic on the R console, you can see here that I am trying to store the data, say here height, this is the data vector height, and I try to create here a scatter smooth graph of height. This will come like this. So, this is the same one which we have shown here on this slide. Now, there are some more options which are available on this scatter smooth curve, which will give you more interactive things, and that we already have discussed here. So, you can just look into the help and try to experiment with various options. Now, I would like to discuss another type of smooth scatter plot. There is another command in R software which produces a smooth scatter plot, but this plot is a little bit different than what we have obtained earlier. This is essentially a smoothened colored density plot, and this is obtained through a two-dimensional kernel density estimate. You may recall that when we were discussing the graphics in the univariate case, then we had created the frequency density curve, or say density plots, using the kernel estimates. So, there we have defined the kernel functions. Those kernel functions were having some nice statistical properties similar to the properties having in the probability density function. So, that kernel function was for one variable. So, that was a univariate kernel function. Similarly, when we have more than one variables, then in statistics it is possible to handle them through the probability density functions, which are functions for more than one variable. Suppose you have two variables x and y, or three variables x, y and z. Then it is possible to define the joint probability density function of x and y, or joint probability density function of x, y and z. And similarly, the kernel functions can also be defined in a multivariate setup. So, in this case, this plot is going to use the concept of kernel density estimates in two variates, and that is why this is called a two-dimensional kernel density estimate. So, well, we are not going into the detail that what are those kernel density estimates in two dimension, but definitely you should know that what are we going to do and how the outcome has been obtained. And definitely, if you want to know the more details, we already have understood that one of the biggest advantage of R software is that it is not a black box. You can go to the site of R software and there you will see the help menu, and there will be all the details that how this scatter plot has been constructed. Okay, so let us now come back to our slides. And in order to create this type of a smooth scatter plot, the command is smooth scatter, but try to see the difference. Here one letter capital S of scatter is in capital letter, that you have to keep in mind, capital letter, and the spelling is a smooth scatter, SMOOTH in small letters, then S in capital letters, and then ATTER in small letters, and inside the arguments you have to give the data vector, right. And similarly, if you want to have more options, you can see here they are given here, but definitely I am not going to discuss them, but I have given them on the slides. Those slides are with you, and you can have a look, and if you try to use them, you will get a more informative and better graphics. So just try to have a look on the help on this smooth scatter, and you will get all this information, right. So now I would try to first take the same example which I just took in the case of univariate data, and I would try to take the data on, say here, weight, where we had collected the weight of 10 bags of grains in kilograms, right, and this data has been given inside the data vector here, weight. So earlier we had obtained the smooth scatter plot using the command scatter.smooth, and this curve was looking like this. Now I will use this new command smooth scatter on the same data set, and we will obtain the new graphic, and I will try to compare it with the two. So you can see here, when I am trying to use the command smooth scatter for the data on weight, here I get here a graphic like this one. What are these points and what is this showing? Now if you try to recall, the earlier plot that was obtained was like here this. Now if you try to put both these points side by side, you can see here the similarity. You can see here, this is here a point, this is here a point, this is here a point on the earlier plot. Let me call these points point number 1, 2 and 3, and they were created as a dots. Now the same points have been created with this new command smooth scatter, which are here like this, point number 1, point number 2 and point number 3. So this point is here, this point is here, and this point is here, right. And similarly, if you try to see here, now I will use a different color so that you can observe the movement of my pen. These 2 points, they are here, and similarly if you try to here, this point, this is here, and similar to this, if I try to see here, this point 1, 2 and 3 here, these are the points here, so they are here. So you can see here, both these plots are going to give us the similar information, but their structures are different. And now it depends on the experimenter or the statistician or on you people. You have to decide that under the given circumstances, which graph is going to give you much better picture. One situation where this smooth scatter type of plot will be more useful is that when you are trying to obtain the observation and you are not 100% confident about the values, whether this value is 20 or 20.1 or say 19.8, then in that case this type of graphics that we have obtained now using the smooth scatter command, they will be more useful because they will also try to show you the uncertainty involved in the point. But definitely when I am trying to say the value is 20, then definitely the margin of error should be as small as possible, and definitely if the value is 20, then there is no error, and this part is indicated that the values are 20 or 19.8 or 19.5 or 19, or the value 20 is 20.2, 20.5, 21 or 22. This is indicated by the decreasing tint of the color. Now if you try to see in this graphic, you can see here, suppose if you try to observe in this black color one, you can see here the values in the center here are most dark. Similarly, if you try to take here another say anything over any point over here, the middle part has the darkest color, and as we are moving from the center like this here, if you try to see my pen in red color, we are moving towards outside, or in this point number 1, this is the center part, and when we are trying to move from the center, you can see that the color is now decreasing and the color is becoming lighter. So this is what is indicated by this type of curve or this type of graphic. As the color is becoming lighter, that is showing the level of uncertainty. If you are confident, if you are strong that the data value is correct, that is indicated by a stronger color. But if you are weak and you are not confident about the data, then that variation or that uncertainty is indicated by lower tint of the same color or similar colors. So this is how you have to take a decision that which of the graphic you would like to use. And now if I try to take the earlier example where we have collected the height of 50% and this data was recorded inside a vector height, then if I try to create the smooth scatter plot, it will look like this. You can see this because the number of data points are quite large, so this is more concentrated, right. And if you try to compare it with the earlier scatter plot, you can see here earlier we had obtained this thing, and now using the new command smooth scatter we have obtained this plot. So you can see here this point and this point, they are here the similar, and similarly here on the right hand side corner these 2 points and these 2 points, they are the similar. So you can see here that both these graphics are trying to give different similar type of information but in a different way. So now before I go further, let me try to plot these things on the R console. So first let me copy here the data here weight, and you can see here, so this data here is given as here weight, and now I try to copy the same command smooth scatter on the data set weight, and you will see that as soon as I execute it, it gives me this type of information. Now up to now you could see I have taken 2 examples where I have considered the univariate data, and I have created this plot. Now I would try to take a bivariate data, and I would try to show you that how the information can be retrieved and how the information is present in this scatter smooth curve. So you may recall that we had considered an example where we have collected the data on the marks obtained by the students and the number of hours they studied every week, and this data was stored in the variables marks and hours, and based on that I would try to make the smooth scatter plot using the command smooth scatter between hours and marks. And if you try to execute it, you will see here you will get this type of here curve. So this is indicating that there is a sort of a linear trend, and this is also giving you a sort of that what can be the maximum deviation in this data. For example, like this, you can simply have to visualize that what is the difference between the green line and the darkest part of the data, darkest color of the data. For example, darkest colors is here in the center. So this will give us information that how the things are happening. So I would try to show you that how this is executed on the R console. So, you can see here I already have stored the data on hours and marks because we have just used it, and now I try to give here this smooth scatter plot command, and you get here a data like this one. So, now in this lecture I would like to stop, and you have seen that we have discussed that how to construct the smooth scatter plots. We have discussed two types of plots, and in every type of graphic there are different commands, although I am not discussing it because they are exactly on the same lines as we have done several times in the past. So, my request is that you please try to experiment with them. You can take even the same data set and try to see how you can add or change the labels on axis, colors of these dots, and how you can give different types of titles, and how you can incorporate more type of information by using different options available with the command. So, you practice it, and we will see in the next lecture with some more graphics. Till then, goodbye.